All right, the last thing we're doing is something called combustion analysis. And again, this is a typical analysis that would be done in a lab to determine the composition of an unknown substance. And in this case, it's an unknown substance that contains carbon, hydrogen, and possibly oxygen. And so just to give you a little background, so you'll kind of know where these values that we're going to use are where they come from, we have a substance, and they put it in like a little chamber here, okay? We're going to feed some oxygen into that chamber and burn the substance, okay? The products of that reaction are going to be passed through a water absorber and a CO2 absorber. If you remember from some just basic chemistry, when we burn a hydrocarbon, all right, if I have a compound with carbon and hydrogen in it, and I burn it, and remember in chemistry burning just means we're combining it with oxygen, okay, and the products are going to be H2O and CO2, all right. That also applies if there is oxygen in this initial substance as well. Our products would still only be H2O and CO2. Now, the key thing to remember in our method of solving this is if we look at our unknown substance, so I have from before 1.172 grams of hydrogen, I have 6.992 grams of carbon, and I have 9.307 grams of oxygen. Okay, so same process as before. Convert it to moles. Remember to carry it out. Don't round it too soon. Okay, so here's our smallest. It's going to be 1. That's going to be about 1, and then this one is going to be approximately 2. So my empirical formula then is going to be CH2O. All right. And then I'm going to have to go back a slide here because I didn't write down my molar mass. Molar mass is 90. All right. So now I'm going to go, my molecular weight is known to be 90. And the mass of my empirical is 30.026 grams per mole. So if I take my mass here divided by the mass of the empirical, that's going to give me approximately 3. So my molecular formula is equal to C3H6O3. You just multiply the subscripts by the 3. Okay, now in this initial discussion, we really didn't come across any problems where these numbers here were not close to whole numbers. Tomorrow in class, we're going to look at some examples of what do you do when those numbers are not close to whole numbers. And so I will take any questions that you have on the stuff that we've covered in here, and then we will add on to this discussion tomorrow in class by looking at how you deal with when those numbers are not whole numbers in that final calculation.